Hey, this is Shiban Acharya again. In this video, I'll do the homework from section 8.1, the distribution of the sample mean. The sample mean has a symbols x bar. Okay, that's the symbol for sample mean. First question, number one, fill in the blank correctly. Complete the sentence below. Okay, in this question, pretty much you are looking for formula for mu x bar and sigma x bar. Okay, the mu x bar is the mean of the sampling distribution of sample mean. Sigma x bar is standard deviation of the sampling distribution of the sample mean. And the formula for mu x bar is just the mu, which is population mean. And the formula for standard deviation of the sampling distribution of sample mean gonna be sigma divided by square root of n. Okay, that's the formula, and you can select the right answer from the choice that are given. Question number 2, and there is a question you have to use the applets, and I'm going to open the MyLab Math for that. Okay, this is the question number 2, and uh, whenever you see on the top, say open the sampling distribution applet, and you have to finish the part A through E. Okay, and whenever you click this sampling distribution applet, this was this applet here, and this is the graph. You can see that this is the population graph. Okay, and this population has a mean 25, median 25, and standard deviation 5. Okay, that tells you, and you notice that this population is normal. Okay, and we don't know what's the size, but this population is normal. You can definitely see that. And the part A says, okay, you have a population, and let's choose the sample size of 4. Okay, in other words, type 4 here. That means you choose one sample of size 4 from the population. Alright, now let's click one time. That means here you can see that there is 4 sample, 1 2 3 4 sample. You choose 4 sample one time, and you find the sample mean. That's going to be here. Remember that this third graph represents sample mean. Okay, therefore this 4 sample has a mean, which is called sample mean. This is here plotted in this graph. Okay, now choose another sample randomly. Click one times again. Therefore, how many samples you have so far? Number of sample is 2, because I choose 4 sample first time. Again I choose another sample first time, and I get 2 sample, and I plot 2 sample mean here. Notice that looks like both sample mean is the same. Now you keep on doing this until 5002 times, but we choose this 1000 times one time. Therefore I have a 1002 samples. Again 1000 times I have 2002 samples. Again 1000 times 2002, 4002, and 5002. That means says click 1000 times 5 times. Therefore you're going to be total sample going to be 5002 samples, correct? And all 5002 samples has a mean. That is 5002 mean. Therefore you plot 5002 mean here, you get this distribution. And next question is, what is the shape of the distribution of 5002 sample mean? The answer is approximately normal. You can see that's obviously, and you check answer, you're good. Now if you notice here on the right of the third graph under sample mean, what is the mean of the sample mean? That's the question I asked. What is the mean of the sample mean? Obviously mean is 24.98. that is close to 25, right, which is same as population mean. Therefore in this question, what is the mean of the sample distribution of 5002 sample mean close to? Obviously 25. Make sense? Check answer. Okay, now look at the standard deviation of the sample means. What is the standard deviation sample mean? 2.5241. And is that number going to be greater than population standard deviation or less than a standard deviation? That's the question. Is the standard deviation of 5002 sample means greater than or less than or approximately equal to the standard deviation of the population? Obviously this is less than, because this is 5 here for the population, and this is the standard deviation of the mean of the sample mean, which is going to be less than. Okay, final check. Next question here is a bit longer. Okay, this is the similar to the previous one. Here we choose the sample size of 4, but here it actually choose sample size of 16. Therefore we type 16 here, type 16. Right now let's click. Now you listen, what you're doing here is we pick sample size 16 before we pick sample size 4. We increase the sample size to 16. Okay, now how many samples have we picked? 1000, 2000, 3000, 4000, 5000. Okay, I have a 5000 sample size, sorry, 5000 samples of size 16. It makes sense to you. Okay, now and the question asks you, hey, in this case, what is the mean of the sample mean? Can you compare it to the previous question with the sample size 4? Okay, remember that in the sample size 4, mean of the sample size, sample mean is going to be close to 25. Right? Now here, mean is also close to 25. Therefore, mean, it doesn't changes, and it is approximately equal to the population mean. It doesn't matter whatever sample size is, 4 or 16. But standard deviation for sample size 4 is greater than standard deviation of sample size 16. Therefore, in this case here, is the standard deviation of 5000 sample mean when the sample size is 16 is greater than, less than, or approximately equal to the standard deviation of the 5002 sample mean with the sample size n equals to 4. Obviously is less than. In other words, if you increase the sample size, your standard deviation gonna decreases. That means called standard error also gonna decreases. Make sense? Now what is that close to? Close to 1.2325, which is gonna be almost, you can choose 1.25, right? Make sense? And that's all about this, the question number 2. Let's do question number 3. Alright, question number 3. Consider a random variable is normally distributed. Complete part A through D below. Okay. If the random variable X is normally distributed, what will be the shape of the distribution of sample mean? Okay, if the random variable is normally distributed, the shape of the sampling distribution of sample mean always going to be normal. The answer is normal. Makes sense? If the mean of the random variable X is 60, what is the mean of the sampling distribution of sample mean? That means what is the mu x bar, which is also 60, because you know the mu x bar is same as mu. Okay, remember that 60 is a mean of the random variable, which is mu, and mean of the sampling distribution, which is mu x bar, which is same as mu. Therefore this must be 60. Part C. As sample size increases, what happens to the standard error of the mean? Remember that standard error of the mean is same as sigma x bar, which is standard deviation of sampling distribution of sample mean. And as we know from the applet in question number 2, as sample size increases, standard error decreases. Okay, Therefore we choose the answer standard error of the mean decreases. Make sense? And part D, if the standard deviation of the random variable x is 15, now here 15 is sigma equals to 15 because standard deviation of the random variable x, and the random sample size n equals to 15 is obtained. What is the standard deviation of the sampling distribution of the sample mean? Therefore you are looking for sigma x bar, and the formula is sigma x bar equals to sigma over square root of n, and sigma gonna be 15 divided by square root of n is, oh sorry, sigma is 15, square root of n is also 15, 15 over square root of 15. And here don't do any simplification, write this answer in the box here, because question say type exact answer using radical as needed. Therefore you have to type exact answer 15 over square root of 15 without using calculator. Okay, question number 4. Complete the sentence below. There is a drop down menu, you select the right answer. The standard deviation of the sampling distribution x bar is denoted by sigma x bar is called the standard error of the mean. Here you choose standard, in here standard error of the mean. Okay, we choose standard error of the mean. Okay, again sigma x bar is called standard error of the mean. Okay, that's the answer. Question number 5. Is that statement below true or false? The distribution of the sample mean x bar will be normally distributed if the sample size obtained from the population that is normally distributed, regardless of the sample size. That is true. In other words, if population is normal, if, then sampling distribution of sample mean is always normal, regardless of sample size. Therefore sampling distribution is always normal. And again, regardless of sample size, whatever sample size you pick, sampling distribution is always normal. Okay, question number 6. Determine mu x bar and sigma x bar from the given parameter of the population and sample size. And pretty much we're looking for mu x bar formula, which is sigma x bar formula, sigma over square root of n, mu x bar formula, which is just mu. Again, what's the mu x bar, which is going to be just mu, which is 80. Sigma x are going to be, sigma is 24 divided by square root of 64, which is going to be 24 divided by 8, which is going to be 3. Okay, therefore you write 80 as a sigma mu x bar, which is 80, sigma x bar, which is standard deviation of sampling distribution, which is 3, and mean of the sampling distribution, which is 80, because mean is 80. Remember that this is the mean of the population, which is 80. This is the mean of the population. It's the same as mean of the sampling distribution of sample mean. Question number 7. Complete part A through D for the sampling distribution of sample mean shown in the accompanying graph. Okay, here's a graph here. Listen, this is the x bar graph. Okay, and this point here is mu x bar. Notice that this is the sampling distribution of sample mean graph. Therefore this 500 is mu x bar, which is going to be 500. Over here the question is mu x bar is 500. Make sense? And what is a sigma x bar? and this is sigma x bar. Okay, hold on a second. This is the sigma, this is the mu, which is same as mu x bar, and this is the sigma x bar. Therefore sigma x bar, because this is, remember that this is the x bar graph, therefore this distance from 500 to 540, the difference is sigma x bar. Sigma x bar is going to be 540 minus 500, which is going to give you 40. Okay, sigma x bar is 40. Okay, if the sample size is 16, okay, sample size is 16, what is likely true about the shape of the population? Notice that sample size 16 is what, less than 30. If n is less than 30, sorry, less than 30, okay, less than 30, we must have normal population for sampling distribution to be normal. That's the criteria. But here our sample size is less than 30. That means the shape of the distribution of the population must be approximately normal. That's the answer to C, because the sample size is less than 30. Okay, by the time your population has to be approximately normal. But if you pick sample size bigger than 30, doesn't matter if the population is normal or not normal, sampling distribution always going to be normal. Therefore here the answer is C, because sample size is less than 30, shape of the distribution of the population is approximately normal. Part D, if the sample size is 16, what is the standard deviation of the population from which sample is drawn? Standard deviation of the population, we are looking for sigma here. Okay, what's the formula? Sigma over square root of n equals to sigma x bar. That's the formula. Let's put the value of sigma. We don't have it, by the way. Square root of n is 16 equals to sigma x bar is 40. Okay, again this is the sigma. Okay, this sigma sigma over 4 equals to 40. Okay, now you simplify for sigma, multiply by 4, both sides of the equation. Let's cancel. Sigma equals to 160. Therefore in this case sigma value must be 160, which is the standard deviation of the population. Okay, question number 8. Here basically use sigma x bar formula and mu x bar formula. Use this formula, and here listen, sample size equals 56, which is greater than 30. Remember that n equals to 56, which is greater than equals to 30, right? Therefore here the sampling distribution is always normal. It doesn't matter if the population is normal or not normal, sampling distribution is always normal because sample size is bigger than 30. Okay, therefore you can use the formula and you can finish yourself. Here this is mu x bar is same as mu, and sigma x bar same as sigma over square root of n, and every information here rounded to 3 decimal places, you get the answer. Okay, that's pretty simple. Okay, question number 9. Determine whether the statement is true or false. If it is false, rewrite it as a true statement. A sampling distribution is normal if only population is normal. You understand what is the question asking for? A sampling distribution is normal if only the population is normal. That's not always true. Answer is A. A sampling distribution is normal if either n equals to greater than 30 or population is normal. There's two criteria. Either population has to be normal or sample size must be greater than 30. Either or. In both scenario, the sampling distribution is normal. Okay. Question number 10. The height of fully grown tree of a specific species are normally distributed. See, here the population is normal. That's given here. Therefore, it doesn't matter what sample size you pick, you're good here. With the mean of 74.5. Therefore, this value here is mu. And the standard deviation of 6 feet. 6 is a sigma here. Okay, standard deviation of the population. Then you have a mean and the standard deviation. Random size of 18 sample are drawn from the population. Therefore, here n equals to 18. Listen, this is less than 18. You find because the population is normal. Doesn't have to have greater than 30 because standard deviation, sampling distribution is normal if population is normal. Doesn't matter whatever sample size is, regardless sample size. Okay, here the question is find the mean and the standard deviation. What's the mean? Mu x bar is same as mu, which is same as 74.5, and the answer is 74.5. And the standard error, also called standard deviation of sampling distribution, what's the formula? Sigma x bar equals to sigma over square root of n. Sigma equals to 6 divided by square root of 18. And if you do the math and round it to 2 decimal places, you get 1.41. Okay, that's the standard deviation of the sampling distribution, also called standard error. Now, which is the correct graph of sampling distribution of sigma x bar? Therefore, look for the mu x bar here. Notice that this line is x bar here. Okay, therefore this is the graph for sampling distribution, and the correct graph is B. You guys see that this is the mean here. You add 1.41, again 1.41, you get this points. Okay, this point is 2 standard deviation above the mean. This point is 1 standard deviation above the mean, and that's the correct answer, number 10. Question number 11. Question number 11. A simple random sample of size 81. Remember that sample size is 81. Okay, is obtained from the population that is skew right. Population is skew right. Okay, here population distribution doesn't matter because sample size is greater than 30, which is 81. So question number part A is describe the sampling distribution of x bar. In this case, the sampling distribution is approximately normal because sample size is 81, greater than 30, and you pick the answer as a C. Okay, and then you answer find the mean and the standard deviation of the sampling distribution of x bar. In other words, find mu x bar, which is same as mu and which is same as 81 here. Here's a mu, and sigma x bar formula is sigma over square root of n is 18 divided by square root of 81, which is going to be 18 divided by 9 is going to be 2. Therefore, standard deviation of sampling distribution is 2. Part B. What is P x bar greater than or equals to 84.4? Okay, here we are looking for the probability of sample mean greater than 84.4. Here the picture looks like. I don't have to draw the picture every time, but one time I'll draw it. For B, this is x bar. All sample mean gonna be here on this line. That's the graph looks like because we know the sampling distribution is approximately normal. and this is going to be just 81, okay, and again which is same as what, mu x bar, which is same as mu, by the way. And now we're looking for the probability x bar greater than 84.4. 84.4 is here, somewhere here, let's say here, okay, let's say this one. It's 84.4. No, this is the x bar here, this is the x bar, and greater means this area, okay, this area. And to find the probability, you're looking for this area, and in this area this point here is lower bound, okay, this point is lower bound is 84.4, and upper bound is on the right, but I didn't know, or we don't know how far upper bound is. Here upper bound is going to be 10 to the power 99 as a upper bound. We use UV as upper bound. And to find the area for this area, which is same as the probability, you got to using normal CDF. It's like chapter 7, okay, normal CDF, lower bound, comma, upper bound, comma, mean, which is mu x bar, and sigma x bar, okay. That's the standard format you put in the calculator. Use normal CDF, use lower bound, upper bound, mu x bar. Notice that we're using sampling distribution of sample mean, therefore we use mu x bar and sigma x bar, not just sigma, because this line represent is x bar, okay. Here let's put in the calculator. What you're going to basically put in is normal CDF, lower bound is 84.4, upper bound is 10 to the power 99, mu x bar, which is going to be 81, comma, sigma x bar going to be 2. Put everything in the calculator. Let's see what you get. Okay, here's your calculator, and using normal CDF, which is under second VRS, normal CDF is number 2, and use lower bound 84.4, comma, upper bound 10 to the power 99, comma, mean is 81, comma, standard deviation is 2, close parenthesis, and this is the area, 0.04456. If you round it to the 2 decimal, because instructions say round it, sorry, not to 4 decimal, I guess, 4 decimal, your answer is going to be 0.0446. This answer is going to be 0.0446. Okay, 0.0446. When you round it to 4 decimal places, make sure that 0.0446. Okay, and that's how you find it. And similarly for the part BC, you can do the same way. Okay, and for part, I just want to write it down, but you guys finish yourself. Okay, this is for part A. For part C, you do this normal CDF, and notice that we are less than equals to 76.9, therefore you have no lower bound. Your lower bound is negative 10 to the power 99, comma, upper bound is 76.9. Remember that this is other way, okay, and mean is again 81, standard deviation is 2. Remember that we're using standard deviation of sampling distribution, and this equals to 0.0202. okay, 0202. You can pause your video and finish yourself. But for this one you do similar, but this is going to be lower bound, this is going to be upper bound, and you do exactly same as we did for B and C. Your answer is going to be 0.8976. okay, That's question number 11. Question number 12. A simple random sample of size 12. Remember that here size is 12, less than 30. Obtained from the population with mu equals to 62. That's the mean of the population. Sigma equals to 18. That's the standard deviation of the population. But population distribution is not unknown. Is not known, right? But the first question asks you, what must be true regarding the sampling distribution of the population? Notice that the question asks you, what must be true regarding the distribution of the population in order to use the normal model, okay, to compute the probability. That's the question involving sample mean. Notice that pretty much the question is asking when sampling distribution going to be normal if sample size is 12, less than 30, and by the time if sample size is less than 30, the population must be normal, or should say population must be approximately normal, so that sampling distribution of sample mean is going to be normal. Therefore, in this question, answer is D. The population must be normally distributed. Okay, makes sense? So the sampling distribution of sample mean going to be normal. Now, if we use the normal model, what's the mean and the standard deviation? Okay, the mean going to be 62, obviously. Here all has 62, but the standard deviation going to be sigma over square root of n. N is 12. Therefore, this is the answer. Okay, for B. Remember that this is the formula: sigma over square root of n. N is 12. Okay. Now, part B is similar to part B of question number 11, and here we use mean as 62, standard deviation as 18 over square root of 12, and this is the upper bound because it's less. Okay, let me do the B, and you can do A by yourself, sorry, C by yourself. A normal CDF, notice less than 66.1. okay, that means 66.1 must be upper bound because we are on the less side. What's the lower bound? Negative 10 to the power 99. Since we didn't have any, because less than 66.1 is, we don't know how far less. 66.1 is upper bound. The mean is going to be 62, and the standard deviation here is going to be 18 over square root of 12. Okay, now you put that everything in the calculator. Let me show you how it is done, and you get the answer. Again, you do start, second VARS. That's how you find the normal CDF. You press second and VARS, and you do number 2, and you find this number, or type negative 10 to the power 99. This is the negative 10 to the power 99, comma, mean is upper bound 66.1, comma, 62 is mean, comma, and standard deviation of 18 divided by, you type C is square root here, second square root, okay, of 12. And now you're closing square root first, and you're closing this parenthesis second. Okay, remember that this one for square root 12, this for normal CDF. Press enter, you get 0.78495, but if you round it 4 decimals, it's going to be 0.7850. okay, it's going to be 0.7850. and that's the probability of X bar less than 66.1. And you can finish yourself for question number 12, and that answer must be 0.3864 if you round it to 4 decimal places. Okay. Question number 13. The length of the lumber a machine cut are normally distributed with the mean of 86 inches and the standard deviation of 0.7. Remember, this is the mu, this is the sigma, and we know that all the cut of the lumber is normally distributed with the mean and the standard deviation. And part A, what's the probability that a randomly selected board cut by a machine has a length greater than 86.22 inches? Here we look for this part A, you look for probability of X greater than 86.22. Notice that here, what's the probability that a randomly selected board cut? Okay, or randomly selected board cut. But here, probability of X greater than 86.22. But for part B, you're looking for sampling distribution. A sample of 41 board is randomly selected. What is the probability that their mean length is greater than 86.22? Here, part B, we're looking for P X bar 86.22. You guys see the difference here? We use X here because this is X comes from the population. This is the sample mean. See, what is the probability that their mean length, see, the mean length greater than, here has all length greater than, okay, here all length is X, all length is X, here mean length is what? X bar. Therefore, in these two questions, you guys see the difference is X greater than 86.22, X bar greater than 86.22. Okay, and here pretty much it is similar, is normal CDF, and since you have greater, you do this as a lower bound, right? 86.22 comma upper bound 10 to the power 99, since we don't have any, because greater than, a mean is going to be obviously 86, but the standard deviation here we're going to use as a population 0.7 because of X. But since the second part using X bar, therefore here you get this normal CDF 86.22 10 to the power 99 86 comma. Now standard deviation, we are not using just 0.7, we're using 0.7 divided by square root of 41. Okay, that's the sample. See, 41. Make sense? And therefore, the difference here is use different standard deviation. Other than that, everything is same. Since we are using X here, we're using X bar here, and you get the different probability. And for this one, the probability going to be 0.3767. For the other one, going to be probably 0.0221. Okay, and you pause the video and try yourself. That's to the answer. Question number 14. Given a normal distribution with the mean 102 and standard deviation 20, this tells you the population is normal. Okay, and given you select the sample of n equals to 16, complete part A through a D. Okay, this is pretty much similar to we did before. Since population is normal, doesn't matter whatever sample size going to be, the sampling distribution of sample mean is always normal. Okay, and you know that mean of the sampling distribution mu X bar is same as 1 or 2, which is same as mu, right? And sigma X bar is same as sigma over square root of n, which is going to be 20 over square root of 16, which is going to be 20 over 4, same as 5. And these are the mean and the standard deviation of the sampling distribution of sample mean. And we have to use this mean and standard deviation to find the probability. I do part A first, okay? Looking for find the probability x bar less than 94, okay? Less than 94 means we don't know how less, therefore lower bound doesn't know, right? We don't know, correct? Because less than, it's a less than, but how far we don't know. Therefore lower bound is going to be negative power 10 to the power 99. That's the lower bound. And upper bound is going to be, upper bound is of course 94, because less than 94, and 94 must be, everything is less than 94. 94 is the biggest number, which is low upper bound. I'm going to use this number in the normal CDF, right? That's what you do every time. Normal CDF. Lower bound negative 10 to the power 99, comma, upper bound 94, mean 1 or 2, standard deviation 5, okay? And I put that in the calculator, okay, and I get the probability. Let's put that in the calculator. And to find this probability, you have to put in the calculator. You do second PRS, and normal CDF is number 2, and you have first number you put is negative 10 to the power 99, comma, upper bound is 94, comma, mean is 1 or 2, comma, standard deviation is 5. Notice that you have to use the standard deviation for sampling distribution 5. Enter, you get the answer 0.05479. If you round it to 4 decimal places, that's the instruction says, round it to 4 decimal places, okay? Therefore the answer must be 0.0548, okay? 0.0548, that's the answer, or that's the probability of x bar less than 94. Okay, part B is similar, and in the part B you use 94 as a lower bound, 94.5 as a upper bound, and use this mean and standard deviation in the normal CDF, and you get the answer, and the answer must be 0.0120. You pause the video and try yourself. Part C, what is the probability that x bar is above 103.4? Therefore we are looking for P probability x bar greater than 103.4. Notice that 103.4 is lower bound here because we are in the greater direction, greater than 103.4. How big x bar goes, we don't know. Therefore in this case use lower bound is 103.4, upper bound you use 10 to the power 99, and of course mean and the standard deviation are given here, and use normal CDF with this upper bound and lower bound, you get the probability. The answer is 0.3897 if you round it to 4 decimal places, okay? Okay, pause the video, try yourself and see if you get the answer or not. Round it to 4 decimal, you see that. Part D is slightly different. There is a 64% chance that x bar is above what? Therefore you're looking for x bar here, okay? And to find the x bar you need to use INVNORM, INVNORM, if you remember that. INVNORM is the option to find x or x bar, but here we're looking for x bar, but 64% above this value, above the value that we are looking for. But how much percent below? If you subtract 100% minus 64%, what you get is you get 36%, right? Okay, let me make a graph for this situation, okay? This is the x bar, okay? And this is the mu x bar, which is same as 1 or 2, correct? X bar. And now this is the standard normal curve. And I'm looking for X value here, X bar. Not X value, X bar value. Where area on the right is 0.64. Therefore, here's the thing. I'm looking for this points here. I'm looking for this X bar. That's what I'm looking for. From where area on the right is 0.64. Because above what value, okay? Therefore, 64% area included on the right of X bar. On the left of X bar going to be 0.36, okay? Remember that if you add them, you're going to get one area. And since to find the value of the X bar value, you have to use INVNORM, okay? INVNORM. INVNORM, and we have to use left area, comma, mean, comma, standard deviation. But in this situation, we are using this mean and standard deviation. Of course, mean is the same as population mean here, but standard deviation is 5 for the sampling distribution of sample mean. For rather than using 20, we have to use 5 as a standard deviation because we're talking about the X bar here, which is sampling distribution of sample mean. Okay, and now how you put in the calculator? Let me finish writing INVNORM. Left area is 0.36, comma, mean is 1 or 2, comma, standard deviation is 5. Okay, and let me put that in the calculator, which gives you a value. Let's see, number 3 INVNORM. Again, some of you have different type of the calculator. It might say left area, mean, standard deviation option. You got to put whatever mean is, whatever standard deviation of this value. Okay, but here I'm putting in that format: 0.36, comma, 102, comma, 5, close parenthesis. I get 100.2077 rounded to 2 decimal places. So that's the answer going to be 100.21. Okay, therefore this value going to be 100.21. Therefore this point here 100.21. Therefore above 100.21 there are 64% chance. This makes sense to you? In other words, we can say that the probability X bar greater than 100.21 is equals to 0.64. That's what we mean. Okay, but we're looking for X bar here using INVNORM. Okay, that's question number 14 is finished. Question number 15. The length of the human pregnancy are approximately normal with the mean 266 days and the standard deviation 16 days. Complete part A through F. That is a bunch of the part of this question. Okay, the first part of the question is what is the probability that a randomly selected pregnancy lasts less than 260 days? For here you select one or randomly selected. Okay, pregnancy lasts less than 262 days. Therefore in this case the value of n equals to 1, and here we are not taking sample of size whatever more than 1. Okay, unlike other question part B, see sample of 33, other question sample of 107, but here sample of 1, pretty much single. Therefore in this question you're looking for P, probability of X greater than, not greater than, less than, X less than 262 days. Okay, 262 days. Therefore that's what I'm looking for. And in this case use normal CDF again. Normal, let me write on the bottom, a normal CDF. since you are less, lower bound is 10 to the power 99, upper bound gonna be 262, the mean gonna be 266, standard deviation gonna be 16. Okay, that's the number. And you put that in the calculator, everything in the calculator. Let's see what you get. I pause the video and I'll put your calculator and I'll show you that. Okay, you try yourself. Okay, I put everything in the calculator. What I get here is 0.40129. If you round it to 4 decimal, going to be 0.4013. Okay, I'm going to put that here. 0.4013. That's the probability of randomly selected pregnancy that lasts less than 262 days. Listen, there is X here, not X bar, because size of the sample is 1. Right? Therefore, we use X here, not X bar. Make sense? Now, answer part, other part here. This is the all randomly selected pregnancy. Therefore, if you select 100 pregnancy, you multiply 0.4013 times 100. What do you get? You get 40.13. This is about what? About 40. Okay, and therefore in this case, if you choose the answer C, read the other option. C makes sense here. If 100 pregnant individuals were selected independently from this population, we would expect 40 pregnancy last less than 262 days. Okay, other ones say exactly, that's not correct. Other ones say more than, that's not correct. Therefore, answer is C for this question number 15. Alright, look at the part B. Suppose that a random sample of 33 human pregnancies is obtained. Listen, this is 33 here, sample size n equals to 33. Now we are talking about the sampling distribution of sample mean. Therefore, question is describe the sampling distribution of the sample mean length of the pregnancy. Alright, the sampling distribution of X bar is normal. You know why? Because the population is normal. See, the population is approximately normal with mean 266 and a standard deviation 16 days. Since population is normal, sampling distribution is definitely normal. Therefore, we write sampling distribution is normal with mu X bar same as mu, which is 262. Remember that mu is 266, not 62. 260. And standard deviation is sigma X bar equals to sigma over square root of n. What is sigma? 16 over here. Over square root of n is square root of n here is 33. And if you put the calculator, you get 2.7852 if you round it to 4 decimal places. Okay, that's the standard deviation for sampling distribution, 2.7852. Now part C. What's the probability that the random sample of 33 pregnancy has a mean gestation period 262 days or less? Here we have a sampling distribution because the sample size 33, which mean, you can see here the word mean gestation period 262 days or less. Therefore, here we are looking for probability of X bar less than equals to 262. Okay, in this case, remember that n equals to 33. Makes sense? And here in our case here, this n equals to 1. Notice that. So that we don't have X bar. See here n equals 33. Let's find this one. Okay, to find this, use normal CDF again. You have less than, therefore negative 10 to the power 99, that's the lower bound. 262 is upper bound. The mean is 266. The standard deviation is, now you're using 2.7852. Okay, put that everything in the calculator, and I did input in the calculator. You see here, normal CDF -20/99, comma 262, comma 266, comma 2.7852, and I get 0.0754. If you round it to 2 decimal, you get 0.0755. Okay, therefore it's going to be 0.0755 and 0.755. And if you multiply by 100, because I got to interpret the probability, to interpret again I do the same thing. I multiply by 100, 0.0755 times 100, I get 7.55, almost this is 6. Okay, in other words, oh sorry, I'm sorry, this is almost about 8. What I'm saying is, in other words, how do you interpret that? And now interpret, this is the C1. If you read carefully, if 100 independent random sample of size 33 pregnancy were obtained from the population, we expect how many? 8 samples to have a sample mean of 262 days or less. This is the other one is B is incorrect because say days or more, is say more, and other A is incorrect. It says exactly 262 days. No, this is less than or equal to 262 days. Okay, that's the part C. Part D. Again, similar questions with a sample of 107. Here n equals to 107, and again you're looking for P X bar less than equals to 262. Exactly similar, but what's the difference here? We are using another standard deviation. Okay, what's the standard deviation you're using? Let me write it down for you. Normal CDF -10^99, comma, mean here is, oh sorry, this is the lower bound, upper bound is 262, mean is 266. The standard deviation here you're using is 16 divided by square root of 107. If you put that everything in the calculator, everything you type in the calculator carefully, you get the value 0.0049. Okay, that's the probability. And for D, your probability is going to be 0.0049. To interpret that, you multiply by 100. Why you multiply 100? Because we choose 100 independent samples. Therefore, every time I look at the multiple choice portion and I multiply by 100, because every question's answer choice say 100, 100, 100. Therefore, I multiply, you get 0.49, which is approximately equal to 0, right? Makes sense? Because 0.49 approximately equal to 0 if you round it to the nearest whole number. Makes sense? And if you interpret the probability and you look for the right choice, here choice is B. If 100 independent random sample of size 107 pregnancy were obtained from population, we expect 0 samples have mean 262 days or less. Other one is not correctly, say exactly, therefore C is incorrect. S A say 262 days or more, A is incorrect too, therefore only correct answer is B. Okay, next part of the question here, E. What might you conclude if a random sample of 107 pregnancy results in the mean gestation period 262 days or less? Okay, for 107 pregnancy sample, the probability is going to be 0.0049. What do you conclude? This is less than 5%. Remember that 0.0049 0.049. What you get in part D for sample of 107? This is less than what? 0.05. Correct? Therefore, we what conclude is the results would be unusual. So sample likely came from the population whose mean gestation period is less than 266 days. Alright, that's the part E. Part F. What is the probability that random sample of size 17 will have a mean gestation period 11 days, within 11 days of the mean? Okay, here the question, you be careful. Within 11 days of the mean. Therefore, what's the mean here? Mean is 266, right? 11 days from the mean gonna be this. Therefore, we are looking for probability of x bar less than or equal to 266 plus 11 and 266 minus 11. That's the lower bound, and this is the upper bound. This is going to be 255. This is going to be 277. Therefore, pretty much we are looking for the probability x bar in between 255 and 277, because say within 11 days from the mean. That means upper bound must be 266 plus 11, lower bound must be 266 minus 11. And what's the function here? Normal CDF. Negative lower bound is 255, comma upper bound is 277. The mean is 266, comma standard deviation. Notice that standard deviation here is since sample size is 17. Remember that. In this case, n equals to 17. My standard deviation is going to be sigma, which is 16 over square root of 17. You put that in the calculator. Let's see what you get. Let me show you that in the calculator here. Second VRS number 2, 255 comma 277 comma 266. That's the mean, comma standard deviation. Let's type exactly like that. 16 divided by second square gives you square root of 17. You close the square root and you close normal CDF. That's what exactly I type like this. Press enter. I get 0.9954. Okay, and that's the answer is 0.999954. You get? Is that make sense to you? All right, that's how you do question number 15. It's quite long, but that's how you do it. Okay. Question number 16. The shape of the distribution of the time required to get an oil changed at the 15 minutes oil change facility is skew right. In other words, the population is skew right. Okay. However, record indicates that the mean time is 16.5 minutes. That's the mean of the population, which is mu, and the standard deviation of the population is 4.8, which is sigma. Okay, but again, notice that the population is not normal, it's skewed to the right. Completes part A through C. Part A. To compute the probability regarding the sample mean using the normal model, what size samples would be required? Notice that since population is not normal, therefore we should expect the sample size must be greater than or equal to 30 to use the normal model, and therefore answer is A. The sample size needs to be greater than or equal to 30. Part B. What is the probability that a random sample of 40 oil changes? Remember that sample size is 40 oil changes. Okay, results in the sample mean less than 15 minutes. Listen, sample mean less than 15 minutes. What is the probability? Therefore here we're looking for probability of sample mean less than equals to less than 15 minutes. That's what I'm looking for. And this is the X bar here. And to find the probability of sample mean less than 15 minutes, we usually do normal CDF, and since you have less, there is no lower bound, therefore we put negative 10^99 comma 15 comma mean. Notice that mean is same as mu. Okay, this is 16.5. remember that this is mu x bar. Okay, but that's same as mu, therefore we're going to use the same number. But here we're using standard deviation of sampling distribution, which is sigma x bar, but sigma x bar is not same as sigma, but this is same as sigma divided by square root of n. What's the value of n? 40. Okay, we can type this everything in the calculator at once to get the probability. Let me type in the calculator and I'll show you the answer, or you can see here now. Okay, here you go. Let me show you how it is typed here. Okay, you use normal CDF, second VRS number 2, and use negative 10 to the power 99 comma 15, which is upper bound comma 16.5, which is mean comma standard deviation 4.8 divided by second square root 40. That's the square root of 40. Close this square root and close this other parenthesis for normal CDF. That's the answer. You get 0.024. Okay, rounded to 4 decimal. This gives you 0.0241. Okay, the answer is 0.0241. Right down here, 0.0241. Okay, this you get it, 0.0241. Okay, and now for C. Suppose the manager agreed to pay each employee $50 bonus if they meet a certain criteria. Okay, that's the goal. On typical Saturday, the oil change facility will perform 40 oil changes between 10 to 12 p.m. and use this 50 oil change as a sample. And there would be a 10% chance of mean oil changes time being at or below that value. And the question is looking for what is that value where the chances will going to be 10% or less. Therefore here we're looking for, this is the mean line, here is X bar, you can see that's the sampling distribution of mean, and that's the point I'm looking for. This the X bar here, that's what I'm looking for, where the area on the left is going to be 0.10. Okay, this is the chance less than 10%. That means mean oil changes time being at or below at that value that I'm looking for, 10% less chances. Okay, less than what value? That's what I'm looking for. Here I'm using INNORM, INVNORM, INNORM, and use left area. Of course, this is the left area, 0.10. The mean we're using 16.5, and the standard deviation is going to be, we're using not this standard deviation, not population standard deviation, but using standard deviation of sampling distribution, which is 4.8 divided by square root of 40. Okay, let me put that in the calculator and find this, the mean time. It's going to be second VRS, you do number 3 and you do 0.10 comma 16.5 comma 4.8 divided by square root of 40, and remember that this 40 parenthesis here and then another parenthesis for this norm in normal. Okay, close it, and the answer is going to be 15.527. That means if you round it to one decimal, that's the instruction say 15.5. Answer is 15.5 minutes. Okay, that's the answer. Question number 17. Acceptable level for insect flip in a certain food item is 4 insect fragment per 10 gram. Okay, notice that for 10 gram 4 insect fragment going to be acceptable. That's fine. Okay, a simple random sample of 60 10 gram portion of the food item is obtained. 60 10 gram portion, that means n equals to 60 here, results in a sample mean of x bar 4.8. remember that this is x bar equals to 4.8. 4.8 is the mean of those 60 sample. This is sample mean is 4.8. okay, complete part A through C. Okay, what's the sample size? 60, which is large enough, right? Bigger than 30. Therefore, in the question asks you why the sampling distribution of x bar approximately normal. Why is that? Because remember that sample size is big enough. If you don't know population size, we don't know population is normal or not normal in this case. If you don't know what's the population distribution or population size, your sampling distribution is normal if sample size is bigger than 30. Therefore, here you can choose the answer C. The sampling distribution of x bar is approximately normal because the sample size is large enough. What do we mean by large enough? More than 30. Okay, or more than or equal to 30. Makes sense? Okay, part B. What is the mean and the standard deviation of the sampling distribution? Assuming mu equals to 4, sigma equals to square root of 4. Notice that this is the value for mean and the standard deviation for the population. Okay, now what is mu x bar? Remember that mu x bar is same as mu, which is same as 4. This value is 4 here. Sigma x bar equals to sigma over square root of n. That's the formula. Sigma here is square root of 4 divided by square root of n. Here is what? And here is I'll have a 60, right? 6 or 60, and use the calculator and round it to 3 decimal places. The answer must be 0.258. okay, 0.258. That's the sigma x bar. Part C. I did part B. Part C. What is the probability of a simple random sample of 60 10 gram portion? This is again, this is the sample size, and a food item that results the mean of at least 4.8 insects fragments. Therefore, we're looking for probability of x bar. At least means what? At least means more than 4.8. okay, remember that it still tells you here in the question, find probability of x bar greater than or equals to 4.8. At least 4.8, that means greater than or equals to 4.8. remember that I use x bar here because in the question, if you read it carefully, it's a mean. Okay, if I have to use x bar here, does that make sense to you? Now to find that, we use normal CDF as usual. Normal CDF. Since you are greater than or equals to 4.8, 4.8 is lower bound, upper bound is 10 to the power 99. The mean is 4. Okay, the standard deviation is this number. We found it. Remember that this is the standard deviation we found for the sampling distribution, which is 0.258. okay, and if you do put that in the calculator, I'm not going to do that since I did all the times. It's going to be 0.001. okay, so for this part it's going to be 0.001, which is very less. Is less than what? 0.05. Therefore, is this result unusual? That's the question. And obviously, since this result is unusual, because the probability is small. Okay, and what might we conclude if result is unusual? What might we conclude? Since we conclude this, since the result is unusual, it is reasonable to conclude that the population mean is higher than 4. Okay, since the population mean is 4, we get the results unusual. That means the population mean must be greater than 4 to make, then these results could be usual by the time. Okay, that's how you conclude. Number 17 is finished. Number 18. In general game of roulette, a wheel consists of 38 slots. 38 slot, number 0 to 0001 up to 36. That is 38 slots. To play the game, metal ball spun around the wheel and allowed to fall into the one of the number slot. Okay, if the number of the slot of the ball falls into matches the number you selected, you win $35. Otherwise, you lose $1. Okay, that's the question. All right, and the first question is construct the probability distribution for the random variable x of winning of each spin. Okay, x is 35. 35 means if you win, you get 35. What's the probability that you win? Okay, since you select one number out of 38, therefore 1 over 38 is probability that you win. Remember that you rounded to 4 decimal places. Since you divide 1 divided by 38, you get 0.0263. Okay, that's the 4 decimal. Therefore, you put here 0.0263. And what is the probability you lose? Probability to lose gonna be lose gonna be 1 minus 0.02363. Okay, that's gonna be 0.9737. Okay, therefore you have this much 0.9737 is probability of losing, but if you lose it, you lose $1. Therefore you put -1 here, and the probability for -1 is 0.9737. Okay, this is -1 for when you lose it, you lose $1. That means you win -$1. If you win it, you win $35. Okay, there is 2 outcomes here, and the question is, that's the probability distribution. Now you got to find mean and the standard deviation of the random variable x. Okay, now to do that, you have to put that data in the calculator. There's 2 ways to do it. You use a formula or the calculator. I'm going to show you how to do it in the calculator. Okay, this is basically comes from chapter 6. You go to the start number 1, which is edit, and this L1 L2 has to be blank. I just clear L1 and L2 both here. Let's clear here. Now I put the data 35 -1 here. Okay, first column L1, and L2 you put the probability 0.0263. Next column 0.9737. Enter. Okay, now what I'm going to do is, again, this is from chapter 6. Okay, start and the calc number 1. Okay, and one word stat, I type L1, second 1, comma, second 2. Okay, if you have different calculator, and you might need to put frequency list as L2. Okay, we did in chapter 6, section 6.1, and press enter. You get X bar, which is mean -0.052. 3. Okay, a question say rounded to uh, nearest penny. That means could be negative 0.05. Okay, negative 0.05, that's the mean. Negative 0.05, that's pretty much 5 cents. Okay, 0.05. And the standard deviation, you can look at this calculator. That's the standard deviation, 5.76. remember that penny is 2 decimal. 5.76, that's what I'm using here. 5.76, that's the population. Okay, standard deviation in the mean. Suppose you, it's part C, suppose you play game 70 times, n equals to 70. Describe the sampling distribution of x bar. That's the question. All right, now the what's the what is the sample distribution x bar? Okay, the sample here, the first blank here, the sample mean x bar is approximately normal. Why? Because look at the sample size. Why? Because sample size n equals to 70, which is greater than 30 or equal to 30, right? That's why we call approximate normal. What is mu x bar? Remember that mu x bar is same as mu, which is negative 0.05. That's a good to put here. And what is sigma x bar? Sigma x bar equals to sigma divided by square root of n. Sigma here is 5.76. we found here, over square root of 70. We use a calculator, rounded to let's see, nearest penny. That means 2 decimal, which gives you 0.69. Okay, now do the same thing here for not the same thing. For here you're looking for the probability. What is the probability x bar greater than 0? Okay, and notice that to find the x bar greater than 0 probability, you use normal CDF. Remember that greater than, therefore 0 is lower bound, 10 to the power 99 is upper bound. The mean here is, remember that, negative 0.05, it's 5 cents, and standard deviation is 0.69. Okay, we use that in the calculator, rounded to 4 decimal places. You get the provided going to be 0.4711. Okay, part E. What is the probability of being ahead after playing 210 times? Okay, that means here number of trial is 200. You can call n equals to 210. Remember sample size. Here we are looking for pretty much same thing, probability of x bar greater than 0. I mean being ahead is greater than 0. That means at least you earn some money. Okay, but when you play 210 times, and first part D you play 70 times, now you increase number of times 210. What's the chance of you being ahead? You do the same thing, normal CDF on 0, comma 10 to the power 99, comma mean is same thing, 0.05 negative, comma. Now standard deviation here is not the same number we used before, because standard deviation always use sampling standard deviation, but here sample size is 210, so you have to use 5.76 divided by square root of 210. Okay, and you use that in the calculator, everything together, 210 here, and that is square root. Let's see what you get. Let's try second VRS number 2, 0, comma 10 to the power 99, comma, the mean is negative 0.05, comma, standard deviation is going to be, you type exactly all the numbers as you see over here, 5.76 divided by square root of 210, close parenthesis, and you close this for normal CDF, and you get 0.4499. We round it to 4 decimal, that means up to here 0.4499. okay, we write down here 0.4499. okay, part F, what is the probability of being ahead after playing 700 times? Now number of times you play the game gonna increases. Here n equals to 700. What's the probability? We do exactly same thing here, exactly same thing, except we put this standard deviation as 5.76 divided by square root of 700. okay, all gonna be similar, and you get the probability. Let me put that back in the calculator and show you what you get. You put all exactly same, okay, except this sampling standard deviation gonna be this number. okay, second VRS number 2 and 0, comma, 10 to the power 99, comma, minus 0.05, or it's negative 0.05, comma, and you have 5.76 divided by square root of 700, right? 70. Okay, here you go. And you type it, you get 0.4092. If you round it to 4 decimal, 0.4092. For this one, you get 0.4092. Let me write down here. This one is 0.4092 for 700. For n equals 210, 0.4499. 0.4499. okay. Okay, and what you notice here is as a sample size increases, and it's 70, and it's 210, and it's 700, as the sample size increases, probability of being ahead is decreases. That means if you're playing more and more game, you are losing the money, because probability of being ahead goes down. Therefore, what you conclude here is the probability of being ahead decreases as the number of game played increases. You see that number of game play increases, probability of being ahead decreases. That's the answer. Is part B is the answer for last question. okay, all right, now we have a last question here, not the last, I think it's 1922 question here. Without doing any computation, put the following order from the least to greatest, assuming the population is normally distributed with mean 150 and standard deviation 25. And the question is, they give you 3 numbers here, A, B, C. Question number 19. Question number 19. Without doing any computation, put the following in order from the least to greatest. Therefore, this goes to greatest here, GREATEST, and this goes to number 1 goes to the least. Remember that these all are the probability. Okay, these all are the probability of X bar in between 130 and 170, and same thing for B, same thing for C. But what's the difference here is, in first case, the random sample of size 40, second questions sample size 50, and third sample size is 1. okay, sample size is 1 because there's X here. okay, and X bar is sample mean, therefore here you see size is 40, and exactly the same probability with different sample size, right? And the question is, which one is bigger? Is that bigger, or other one is bigger, or other one is bigger? Which one is bigger? That's the question. And here's the idea: if n is larger, sigma x bar is smaller. Okay. In other words, standard error, STANDERD, standard error from the mean increases, decreases. If standard error decreases, the probability increases. Probability increases. Okay. Therefore, if n is larger, your standard error going to be smaller, right? And then by the time probability increases. Therefore, here the greatest probability in this case is the B, because the sample size is large, right? And the smallest probability is C, because size is 1 for C. For middle, of course, B is in the middle. Okay. Oh, sorry, not B. A is in the middle, because I already have B here. A has a size 40. Therefore, you see that since this B has size 50, therefore this probability is more. Therefore, we put B is the greatest one. Or you can do, we can find the probability using calculator and see which one is larger. But that's what the order is going to be. Okay, as long as more sample size, the probability is more, and less sample size, probability is less. Does it make sense? That's the question 19. Okay, question 20. This is the last one here, and we're done with the section. Suppose Diana and Jack are each attempting to use simulation to describe the sampling distribution of population that is skewed left with the mean of 60 and standard deviation 5. Okay, here you go. Population here is skewed left. Mean of this population is going to be 60. Standard deviation sigma is going to be 5. This is the population. I don't know, but they want to do the sampling. But notice that this population is not normal. Okay, because the population is not normal. It's skewed left. Skewed left population is not normal. Okay, Diane want to do the sampling. Diane, D-I-A-N-E. Diane make 100,000 sample of size 5. Okay, from this population which is skewed left. Make sense? And find the mean and the means. Find the mean of the means. Remember that mean of the means is going to be sigma x bar. Okay, mean of the means is sigma x bar. And mean of the means, which is sigma x bar. And determine the standard deviation of the mean. That means sigma x bar. That's why you see determine. Diane does 1000 sample of sample size 5. She find the mean of the means and the standard deviation of the means. That means she find mu x bar and sigma x bar. Correct? Jack does the same, but Jack does this. Jack choose 1000 sample of size 40. Okay. Again, notice that Jack sample size is 40, Dan sample size is 5. Okay. Now, what you understand here is for the sampling distribution, Diane Diane sampling distribution is going to be skew to the left. I'm sorry, this is right. Skew to the left. Going to be skew to the left. But Jack sampling distribution is going to be normal. Skew left. Why? Because since Diane sample size is not more than 30, therefore Diane sampling distribution of sample mean going to be skewed left because population is skewed left. But since Jack sample size is 40, Jack sampling distribution of sample mean is normal. Okay, has to be. And first question is based on this discussion. And describe the shape you expect for Diane distribution of sample mean. Describe the shape you expect for the Jack distribution of sample mean. That's the answer I plot in the graph. How do you answer the question? Part B. Diane distribution expected to be skewed left, but less skewed than the original. Remember that. Still skewed left, but less skewed than the original population. But Jack distribution is expected to be approximately normal because Jack has a sample size more than 40. Make sense? Okay, part B. What do you expect to be the mean of the Diane distribution to be? What do you expect the mean of the Jack distribution to be? What do you think? Both is 60. Okay, and this time we expect both distribution mean going to be 60. But if you look at the standard deviation of Diane, sigma x bar equals to sigma over square root of n, which is going to be sigma over square root of n here is 5. That's going to be sigma is 6, by the way. Sorry, sigma is 5 here, right? 5 over square root of 5. That's going to be, if you do the math here, 2.24. That's going to be Diane standard deviation. But Jack standard deviation is going to be same formula, 5 over square root of 40, which is going to give you 0.79. That's the Jack standard deviation. Okay, therefore you have to put this 2.24 for Diane standard deviation, and you put 0.79 for Jack standard deviation. That's the answer. Okay, that's all about this section 8.1. Thank you for watching the video. Alright, for A and B. Okay.